So, folks, first of all, sorry, traffic, and I was definitely not prepared for the traffic in Berlin. Sorry, really. But yes, my name is Dolgov. I'm working as an ML engineer in a company called JetBrains, and basically today I will talk about how to train the fast LLM for coding task. But first, to explain how do it, let's talk about why we need to do it when we have those guys around. I like to refer to my colleague who once said that speed is a feature, and sometimes when you are building your apps or building your solutions around the big LLMs from the LLM provider, sometimes latency is not perfect, sometimes it's slow, sometimes your features are struggling, and so on and so on. So if you have this, I don't know, speed as a feature thing in your mind, that definitely could not be what you wanted. Also, sometimes general purpose LLM are not a perfect match, so very specific task, for example, if there was a lot of this type of data in a training, so that could be also not for you. Also, the cost sometimes could be very different if you have, for example, a lot of pre-filled tokens and not a lot of, but a small amount of output tokens. It could be kind of expensive for you. So that's also is one of the moments. And also, you don't have control over data distribution. These folks could generate code or generate this code of snippets of code or something like this differently than you wanted, and sometimes prompting is the hell. And yeah, that could happen, and that's a motivation to maybe sometimes build something by your own. What I'm proposing or something, this thing called focal models or small LMs, SLM. Definitely a small language models, less than 10 billion, 14 billion or so, which is highly domain specific for specific purpose, coding or maybe something else. You could do it purpose built from the scratch. It could be post-trained from the maybe some more general thing, like quantization. It doesn't change, of course, the number of parameters, but still could be faster. And of course, knowledge distillation from the bigger one to the smaller one. That could happen. And here today we will talk about one specific example. The JetBrains Mellum, the focal model, small language model, is a 4 billion model designed specially for code completion. It's its purpose is complete code. It can complete it on a different languages. It's costs not a lot of money, secure, energy efficient, and here is a kind of example how it's work. So let's go. The story about the code completion in JetBrains. Basically, before we had anything, we kind of had requirements. It's the code completion should have a context awareness around the project. It should provide best quality or with specified latency. It should be fast and kind of good, cheap, safe, and back then it was a problem, when you prompted the chat model, sometimes when you are sending it code to it, and it started to generate some natural text about I don't know, apologizing or something like this. It was a problem back then, but now probably already it's better. But it was one of the requirements: code in, code out. And before we will go, and I will say you how we did it, let's talk about like code completion itself. What is code completion? Let's imagine that we have file. It's not fully written. It's you have something like below below cursor. It's called prefix, and you have something under cursor. It's called suffix. And basically, sometimes you have relevant files in your projects which can help you to deliver better code completion, and those files which could like deliver, which you can like read with your model and then generate better code completion, we called context. So basically, here are the like terms which I will use, and basically the code completion, what it is. We specified prefix, suffix, and context. We need to generate like a best few tokens, few lines, etc. So like read the mind of the programmer and complete his thought, something like this. It's about code completion. And when we started to develop it, we decided to do it from scratch. Why we decided to do it? We had two wonderful options. First one, LLM providers. Second one, like use open source models. Let's talk about LLM providers. First of all, it's what I was talking before. Input and output tokens in LLM providers costs the same price. That's like one price for like one token or so. And in our case, we generate not so much. We generate like until the end of the line, maybe a couple of lines or something like this. And we have a lot of pre-filled tokens before, like context tokens and so on. And this could be like pricey. So that's like in general cost a lot. Would cost a lot for us. Also, we were a little bit worried about like that models are training not on permissive data, and we could, like as a providers of IDE, could provide the like not I don't know, GPL code or something like this, which is not allowed, and that was a major problem for us. And of course, like users' privacy, we have users, they send in us their like code bases, and share it like with third-party provider would be like a deal breaker for a lot of people. And so here's this like thing with LLM providers. With open source, why not open source? Back then, it was like a year and a half ago, many of the open source models was not like a production ready for like completion. Some of them didn't have like in feeling, some of them didn't have like context inside. It was like a major pain to find like this open source model. But and yeah, that we didn't find. Basically, the same problem with non-permissive data, and we thought that we could do better. We could do better than this. And when we started to work on it, we basically, one of the first problem was how to generate like inside the file, inside the context. Because I will remind you, what is a language model? Language model provides you the most probable token, like with specified prefix, the most probable token. And here you see the prefix. It's like this 3 lines or so, and you will not get a valuable like good information from the suffix if you like have only the prefix or so. And what we can do this in this problem? Let's prompt the model, but in a different way, not like with chat, but a little bit different. Let's put the suffix up before the prefix. Mark is as a suffix, prefix, and middle, and after we will have tokens which we wanted to generate. And so basically, that's it. Language model. Language model. We have like a context before, and then a couple of probable tokens, or like maybe several lines or something like this. So, and this type of object called the fill in the middle object, and I will probably refer to it like a couple of times in the future in this presentation. Yes, so, and this was the first problem, and yeah, it's kind of widely known how to do it. And next problem, the data, where to get the data. We used open sourced data sets, which provided us like a lot of code data. We gathered data sets additionally for specialized model, which I will talk about. Them later. We did several filtering, like processing of the data, but the major one, we rid of the non-permissive permissive licenses, like repo-wise. So if a repository has a like GPL or something like this, we delete it, of course. And also we were going like from file to file and looking is there a license template or something like this, and if this template is also non-permissive, we read of it. And when it happens, sometimes people put non-permissive files in permissive repos. Why they are doing it? I don't know. Talking about training process. Today, in modern LLM worlds, basically the LLM process contains like 3 steps, sometimes like 4, but 3 steps, like in general. Pre-training, supervised fine-tuning, and alignment. And we will talk about every of the step right now, on an example of code completion. Pre-training, how it was done. We gathered like 4.5 trillion code tokens, like from internet. It was already after the filtering and so on. There were like 80 plus languages, 8K tokens context window, and 4 weeks of waiting when it was like pre-training. How the pre-train was look like. First of all, it was unstructured code. It contains like a mix of languages, so files of like Python could be near to JS, could be near to PHP or something like this. We also add the additional metadata to the before the files to like in the future to prompt like it is the project with like I don't know 100 star or like 1,000 star or so. That's a joke. Yeah. So and basically the files didn't have contextual information, and every second file have random fill in the middle objective. What is random fill in the middle objective? Random here, it's about the end of the prefix and start of the suffix. So the middle was kind of random. Why it was random? For generalization. Like the more random it is, the more stuff model see like during the training. And basically, after the 4 weeks, we had a model. It was quite okay. It was completing codes on several languages. It was fine. It like could work. But we wanted to do like it better. But, first of all, better fill in the middle objective, provide language specification, and add context awareness. Let's talk about all these things in a part of supervised fine-tuning. Talking about the fill-in-the-middle splitting. As I said, we had this random splitting before, like during the pre-training. It's look like this. So, but people don't write code like this. They don't expect. I don't know if you write the log action function, you don't expect that it will be like complete you another function at the start of the next one. So that's kind of this problem from the pre-training, from the way we pre-trained. We wanted more generalized model, but in the same way, we kind of heard this objective. And we created the like processing for these splits, fill in the middle splits, to be like more realistic, to be more close to the user, to like to more like human behavior. And here it is. We like generated a lot of data like this and added it to supervised fine-tuning. Also, about language specialization, it's not a secret. If you train on some specific language, you start to be better on this language. And here, here's like a graphs. Here's a model like for one-line completion for Python, like a Python model, like it's a base, that's a pre-trained model with the base model, and specialized one. So it's like a little bit better than base model, but it's for one line. But for multi-line and the next graph there with for multi-line, it's like significantly better. About metric, what is KK? Actually, KK score, it's called like that because it was developed by two my colleagues, Katya and Carol. So it's KK. Yeah, and basically this metric, it's a relaxed exact match for multi-line. So it's the number of corresponding lines in the suggestion, which is intersecting with which is equal to the golden completion. Yeah, so it's basically exact match for multi-line with like reorder with like order. I mean. So the order does not matter. So and yeah, you are training on one language. You started to be better on one language. Yeah, that's it. But also one of the things, it was context awareness. When we are talking about one file, that's like understandable. We know where context is. We know what context is meaningful and so on. But when you have when you have opportunity to get another files, you start asking yourself questions like how to find those files. What parts of the files should I take? How to be sure that context are equal for like a training part, and for the inference part of the of your system. Yeah, and last question: how to gather context not for the one project or like 10 projects, but for like dataset when you have like hundreds of thousands repositories. Yeah, and basically for us, answer was that the technology which we developed called Code Engine, and basically what it is, it's Kotlin library which we can integrate inside our IDEs and which we can reuse on during our preprocessing on MapReduce cluster, which is configured by open source technology called Idzaurus. Yeah, and it's they are providing like Java API, which simultaneously can integrate the Kotlin code and Kotlin libraries, and yeah, basically that's a great thing which we kind of achieved. So that's also for the people who I don't know could follow this Kotlin LM journey. Code Engine was one of the first steps for Cook. It's our AI agent framework, something like this. It was one of the first steps for it. But yes, so basically we kind of rid of this problem that's on inference part, and during training we collect in context with the same, exact same code. That's yeah, kind of cool. And does this context awareness help us? Yes, kinda. As you see, before, for one line, it starts to be a little bit better. For multi-line, for this KK score, that's kind of good amount of better. Yeah. So, and talking about last but not least, alignment. So, why SFT is not enough? Because when we are training, when we are pre-training, and when we are fine-tuning, we always use code which is full, ready to use, which is complete code from GitHub or so. But when user writing code, they don't have a full ready to use code. They're trying to make it a full ready to use code, and basically sometimes the behavior is strange. For example, you are defined a function, it's empty, and your completion model saying arrays not implemented error, but it's not useful. You want good function, you know. You don't want not implemented error. Yeah, but because it was mainly model was seeing it during the pre-training and supervised fine-tuning. I mean that in empty function there is a raise implemented error. It generates raise implemented error. So basically alignment, it's not about to make it smarter. So it's about different form, different style of generation. So basically you can make code generation more human friendly, make code generated code more useful in specific scenarios. Train and because this alignment, the backbone of it, is this array algorithm. You can use not just a good examples of code, but you can use preferences. And talking about preferences, for example, like for people who do not write Python code, sometimes we use pass. It's not do much, but sometimes we use it because, I don't know, for debugging purposes or something like this. Sometimes we even commit it to GitHub, and then model trained on it, and then they started to generate something like this. And this is not useful for a person. That stuff is useful. Yeah, like some widgets, something like this. Yeah, and but in general, how to get those examples, where we find them. On GitHub, we don't have good and bad examples. With user logs, we don't like gather them. We don't gather the like strings from people because it's their code base. We can't do such stuff. Feedback from dog fooding, sometimes sparse, not sometimes, always sparse. You can find, I don't know, major problems, but not some specific detailed things. And of course, we can use alignment datasets, but sometimes like you also think about like and how they get those, like will I have licenses issues and so on and so on. So basically, like what to do. We can ask for help of like other big models. We can actually generate completions with our models, but like with different randomness, like just like I don't know, open the imagination of the model and start to generate like in equal context different things. Then with the help of big LLM, we can like score them, tell like what is better, what is not, what is something else, and so on. And then like we could use this like preferences from the big model to use these pairs for like this one is better, this one is not. And does it help? Yes, does it help? Yes, it helps. So for first line, I mean for one-liners, that's not like a big increase, because there is no increase actually, and actually, like, because the generation of one line is almost always not about the form, not about the like style or something like this. It's useful or not, or something, or something like this. It's so that's kind of okay picture. Yeah, and talking about the multi-line like increases a lot because of you like think about the style, about the form of generation. You don't generate like big splits and generates like fourth sorry I don't know, several functions in a row or something like this. So that's pretty good results. And how we are doing, like comparing to the other LLMs, kind of good. We are making the like a little better results than models twice the bigger, and even like if we are comparing it to IBM Granite on the code completion task, it's all about code completion task. It's kind of better. It's smaller, it's cheaper, and yeah, that's our result. Like, yeah, if you don't know, this Spiral is a AI assistant, and that's us. Yeah, and what we developed with this pipeline. We developed like 3 models: Mellum Pi, which is specialized for Python; Mellum Kotlin, which is specialized on Kotlin; and Mellum All, which is specialized on other languages which are present in JetBrains products. And actually, all of them, not all of them will be on a Hugging Face. Some of them already are. Mellum Pi and Mellum Kotlin. Mellum all will come in soon. So if you want to use it for code completion, if you want to use it for something else, there are also base models and so on. Please do. Here are the color codes. And thank you all. Thank you for the opportunity to talk about it. And yeah, thank you. Yeah, thank you. And questions, please. Yes.
Yeah, thanks a lot. I mean, that was a lot of details. That was really insightful. Thank you.
Yeah.
Maybe one of kind of obvious question would be if we want to add a new language to this knowledge.
Yeah.
Is it okay if we just use one of your models and fine-tuning, or
yes,
do you
yes.
have some suggestion what would be specific steps we need to follow?
Yes. I mean, if we are talking about these 80 plus languages which were in pre-training, you can fine-tune like on it. Definitely. And as I know, some people, well, maybe okay, one person already did it for Rust. And I mean, yes, you of course you can do it. Here is a tricky thing. About this context and about the gathering context. Pretty soon we will also open source this thing like called Mellum SDK, and you can get those like context also how we do it on during the inference part. But before it, you can get the context and to put it in a way as we explained, like in this cards, Hugging Face cards, and it also should be helpful. Yeah.
Specifically, the code engine will be available.
I don't know about the whole code engine, but the parts about the context for Mellum definitely will be.
Thank you.
Thank you for the presentation. If you could share, if it's not a commercial secret, could you like share what's your setup for training the base model? Like how many GPU hours did you use?
Good question. So for this, it was a GPU hours. One moment. We had two versions of Mellum, and it's 64 GPUs for 4 weeks, and it was 128 for 2 weeks. Yeah. So and basically, yeah.
Is it like A100?
Yeah. Yes. It was A100. Yes. But it was for pre-training. Fine-tuning is so much like lighter for this stuff. Yeah.
Do you have any example system prompts for using it with Llama CPP? Because I just tried it and it was terrible.
Oh, yeah.
I asked it to join 2 TypeScript strings and it was like, try this, and just kept going.
Okay. Like a system prompt, like you are useful. Yeah. No, you need to like put the like files with special how it's like tokens, like prompt tokens and so on, and it will generate some like completions. I mean, there is like examples on this Google format. So as I know, there kind of works. Or not? You can try those examples.
Okay, I'll try these examples.
Yeah. I mean, there are in this model card. Yeah. If not, please write the stuff in Hugging Face, and I will come there and like, okay, we will go and see. Yeah. But I was converted it with like my hands. I heard and I saw it was working.
Yeah, I've downloaded the GGUF. It does work, but you need a prompt, so I'll try that.
Yeah. In card you have prompt. But it's not like prompt for chat models. It's prompt for like here the stuff and generate. Yeah. Thank you.
Okay, thank you very much, Ivan.
Thank you so
and
much.
a big applause to you.
Yeah, thank you.